We are at the beginning of the AI revolution, and there's a lot to be learned from the Industrial Revolution. Steam engines represented a complete paradigm shift, helping to start the Industrial Revolution in 1760. But they were also incredibly inefficient, wasting over 99% of their potential energy. It took until the following century, with the development of thermodynamics, for the technology to become truly useful, affordable, and democratized. Today, we are facing a similar challenge with AI. AI is changing the world, but we barely understand how it works, and it's incredibly data and energy hungry. Like thermodynamics, we need to develop a scientific framework that explains how AI works to unlock the tool's promise for radical change. That's what my research focuses on. I'm decoding the computational principles that underpin learning in both brains and machines by understanding the mechanics of learning, from how a brain makes sense of the external world to what constitutes effective decision-making. We can design the simpler, faster, smarter, and more data-efficient AI models of tomorrow, making AI as efficient as human and animals. Why? Because the usefulness of AI is directly tied to efficiency. And the only way we can truly improve efficiency is through a deeper understanding of how learning works in the first place.